Flat puzzles are well known by everyone, but 3D puzzles present a different challenge. These three-dimensional puzzles are first conceived with computer software. Good blades are needed to cut puzzle pieces. Here are the blades for the master die, which will cut out printed sheets of different models. This rubber will be used to eject the die. The master cutting die is unique to each puzzle. It is the specific pattern used to make the puzzle. They measure it meticulously to obtain a perfect register. It's imperative that the die not move during the cutting, otherwise the pieces would be cut at the wrong points, so they very firmly secure it in place. The carbon of the die is positioned. It's somewhat like printing the master. Alignment is again verified, a highly important step which assures the quality of the final product. Finally, they install this large metallic plate, which is the cutting base. It will be on this surface that the master die will strike. Once measurements are finished, the drawer of the die is slid into place. This press cuts the pattern seen on the puzzle. Here's how it works. The sheets, or printed cardboards, go into the drawer one by one, where they are cut according to the master model. We clearly see the press making the cut in the puzzle sheet. The cut sheets pile up on one another, and at this checkpoint, they verify the precision of the cut. They make sure that every piece is correctly shaped. Now they go to the foam support of the puzzle. This guillotine is used to cut the polyethylene sheets onto which they will glue the cut images. Foam sheets are inserted into this laminator, heated to 232 degrees centigrade. The sheet with the design on it is glued onto the foam with a thermosetting adhesive. Now they glue the printed sheet onto the foam sheet. Once the adhesion is finished, the puzzles are stacked on one another, and they proceed to the unbuckling operation. By pulling, they remove the surplus cuttings. The same design is printed several times on a sheet, so they must separate each puzzle. This step is called the reduction of the models. Now the pieces have to be separated. This decorticator handles this task and sends the pieces down a chute. Packing cartons arrive already made up, and the puzzle pieces are placed in their boxes. No less than 15,000 puzzles are produced here each day. Since it began operations, the company has created more than 300 different puzzle models, from quite simple ones to much more complex designs. The largest of them contain a total of 3,146 pieces. And you need real patience for this one. Modern bathtubs look nothing like tubs of the Middle Ages or those wooden tubs we see in Western films. To achieve supreme comfort, the designer explores new shapes via computer and design software, tools which make for speedy review of various shapes. Then a model is produced. This one, produced on a 1/6 scale, is made of cardboard, but other models can be made of clay, polystyrene, or by stereolithography. Manufacturing begins with an acrylic sheet. It is heated to about 200 degrees centigrade with ceramic elements. The sheet becomes soft and malleable. So that it takes the form of the mold, thousands of tiny holes in the shell suction the sheet by vacuum. The mold must cool before it can be opened. Powerful ventilators blow air directly onto the mold, lowering the temperature to 77 degrees in 4 to 6 minutes. The ventilators are then withdrawn. Then the shell is easily removed from the mold, and that's because it weighs a mere 16 kilos. To make a tub in another shape, they change the mold. They put it in another acrylic sheet. It is heated on the ceramic and fiberglass mold. The little holes vacuum out air, and the job is done. At any rate, the molded acrylic sheet is not sturdy enough to be filled with water, so it must be reinforced with fiberglass. This is the fiberglass. Mixed with resin, it is blown onto the mold by a robotic unit. Stored in reservoirs, the resin is carried to the robot by pumps. Here it produces a chemical reaction between the fiberglass and the resin, which produces a reinforced shell. Laminating is one of the most important steps. With brush and roller, they eliminate all air bubbles which could weaken the tub. This makes the fiberglass resin adhere perfectly to the acrylic shell. The process requires 75 minutes. The shell is then transported to the milling department. The shell is now dry and hard. They can extract it manually, but here they use digitally controlled machines. The operation begins with the trimming of the edges of the bathtub. During this operation, the robot will also pierce openings for the drains, the whirlpool jets and the air jets, for the overflow as well as for ambiance light. The bathtub, almost completed, is now sent to another workshop. They can now install the pump, the piping, and the blower. These last operations are done manually. The pump is installed for the whirlpool system as well as the PVC pipes, whose joints have been hermetically sealed to prevent any leaks. Finally, to make sure that everything is functioning well, each bathtub undergoes a water test. Some 13 steps have elapsed, plus 3 to 5 hours of work depending on the tub being made. It almost invites you to climb in.